Hello, everyone, and welcome to our YouTube channel. Before we jump into today's topic, if you find this content valuable, please take a moment to subscribe our channel. It really helps us to bring you more great insights like this. And trust me, when it's come to what we are about to going to discuss, I don't think this particular content is still on YouTube. So you are in for something truly unique and essential. So let's get started. Okay, let's take a quick look at what we will be covering today. So, we will begin by exploring ransomware. We will define what it is, cover its different types, and then we will jump on our next agenda AES encryption. We will understand the core encryption mechanism for our script and the foundational principles behind it. And then we will look at key libraries like cryptography, PBKDF2 and Hazmat. We will also cover setting up your Python development environment. And then finally, we will begin coding the first module. This section will guide you through the practical aspects of AES encryption implementation using the cryptography library, including PBKDF2 and Hazmat. What is ransomware really? So ransomware is a software that holds your digital life hostage and then demand a payout to give it back to you. There are different types of this digital extortion. Like we have ransomware, which locks down your precious files like your documents and photos, and then we have local ransomware, which is more aggressive and it sees your entire computer control. Like you can't even move your mouse. And then we have scareware, which just tries to trick you with alarming fake warnings. And then we have leakware, a truly sinister form that threatens to expose your deepest darkest secrets if you don't pay up. And then we have ransomware as service, or RAS. This is where criminals can literally rent the tools to launch their own attacks. Next, we have AES encryption. So, what stands for AES is Advanced Encryption Standard. It's the backbone of the modern digital security. It's like a strong digital lock that uses a secret key to lock and unlock your data. So, AES is a symmetric encryption method, meaning the same key is used for both locking and unlocking. So, if you encrypt something, you will need that exact key to decrypt it or unlock it. So it comes in strength like AES 128, 192, and 256. The numbers just refers to the key length, and it works in different modes like electronic cookbook and cipher blockchaining and cipher feedback, CFB mode, which are just different ways it handles the locking process. Next, we have block cipher. So, what does it mean that AES is a block cipher? Basically, it does not encrypt your whole message in one go. Instead, it breaks it into small chunks, usually 16 bytes, 128 bits at a time. If the message is short, it adds some extra padding to fill the block. If it's long, it's split into multiple blocks and processes each one separately. It's a clean and efficient way to handle data securely, whether it's a short message like hello or a longer one like hello friend, as you can see on the screen. So, have you ever wondered why encrypted data can look different even when the message and key stay the same? That thanks to the initialization vector, or IV. It's a random 16 byte value added to the first block of encryption to keep things unique. Think of it like putting the same item in 10 identical boxes without any label, then they all look the same. But if you stick a different random number on each box, no one can tell the contents are identical. That number is like the IV. It's not secret, just random, and that randomness is what keeps your encrypted data look different every time. Okay, guys, now let's take a moment to talk about one of the building blocks of encryption, XOR, short for exclusive or. It might sound technical, but it's actually pretty simple and incredibly useful. In AES and many other encryption methods, XOR helps scramble data by mixing your message with either the initialization vector IV or the previous block of ciphertext. Here's the basic idea. If two bits are same, like 00 or 11, XOR gives you 0. If they are different, like 0 and 1, or 1 and 0, it gives you 1. Think of it like a digital mixer, combining two sets of bits to create something totally new. That transformation adds an extra layer of unpredictability and security to your encrypted data. So for this particular series of Python Ultimate ransomware, we are using AES 256 in CFP mode, and there's a good reason why CFB. CFB has a few key advantages that make it both practical and secure. First, it handles padding automatically, which is a big time saver. Even if you are encrypting just a single byte, CFB take care of details. No need to manually pad your data to fit block sizes. Second, CFB does not encrypt your data directly. It encrypts the IV or previous cipher text block, then XORs that result with your plain text. This keeps things dynamic and secure. Finally, each new block of encrypted data depends on the one before it, forming a secure chain. In this project, we will use Python cryptography library. This powerful library offers two main branches of APIs. The first one is low level, and the second one is high level. So the low level APIs gives us full control over cryptographic internals, and they are incredibly powerful, but also require a careful handling. This branch includes the Hazmat submodule of cryptography, which we will discuss next. On the other hand, high level APIs offer simple functionality such as basic file and string encryption and include features like serialization, Fernet, and X509. For our project, we will use Hazmat, which will provide us a low level control. So now let's discuss about Hazmat. Hazmat, as I told you earlier, Hazmat is a module of Python cryptography library. So what is meant by Hazmat? So Hazmat stands for hazardous material. Okay, and as I told you earlier, Hazmat gives us complete low level control over encryption internals. That means we can handle every step of process ourselves, from key generation to data transformation, without the safety nets of high level APIs. This kind of control is incredibly powerful but also dangerous. One small mistake can compromise the entire encryption process. And yes, we are going there. We will be using Hazmat directly into our project because this level of precision is exactly what we need. It's also why we are calling our creation Ultimate Python Ransomware. We are not just using cryptography; we are controlling it down to the finest bit. So coming to the next topic, we have HMAC. So what is HMAC? Actually, HMAC is one of the most crucial component within the Hazmat module, which stands for Hash-based Message Authentication Code. HMAC plays a key role in verifying the integrity and authenticity of a message. It combines the secret key with the hash function to produce a unique code, like a kind of like a digital fingerprint. This let us confirm two important things. First, that the message hasn't been changed. Second, that it comes from a trusted source. Now, it's important to remember HMAC does not hide the message. It does not encrypt any message, any plain text. Its job is strictly verification, not secrecy. So, in our project, we will be using HMAC to verify the integrity of encrypted files. That way, we can detect any tampering after encryption, making sure everything stays just the way we left it. So coming to the next point, we have PBKDF2, which stands for password based key derivation function 2. Now this function is essential for security as it safely converts a password which might be weak or short into a strong cryptographic key which is suitable for encryption. PBKDF2 incorporates several critical components to enhance security like SALT, which is a random value added to prevent rainbow table attacks, like iterations. Now we have iterations determining how many times the password has function runs, significantly increasing the computational cost for attacker. And we have key length, defining the size of final output key in bytes. And finally, the hashing algorithm, which is the core function used to scramble the password and salt. The elements collectively make PBKDF to a robust method for driving secure cryptographic key. Last but not the least, let's talk about the default backend. Think of default backend as the engine running all the cryptographic work behind the scenes. Whenever you call a cryptographic function such as PBKDF to HMAC, it relies on this engine to perform the necessary operation. Specifically, the backend handles key tasks like using hashing algorithms, looping through iterations as specified by the function like PBKDF2, and securely managing byte level operations. In essence, the backend provides the foundational infrastructure for all cryptographic computations. One of its main function, particularly default backend within the cryptographic library, is to intelligently select the most secure and efficient engine available for your cryptographic operations, ensuring the performance and optimal performance and security. Now let's start by downloading Python. Go to the official Python website. The link is in the description. And after downloading, open the installer. Now, after opening an installer, you see multiple options. Now, do as I do. First, we have to click on add python.exe to path, and then before going to customization installation, we have to also check the use admin privileges. Make sure that all these options are selected. Click on next, and then click on precompile standard library. Install Python for all users, and then click on yes. It will takes a bit. Let it take its time and wait for a moment. Now after installation, click on close and open your CMD. Now we will type python version and then pip version. Now after this, type pip install cryptography. Now this will install our main cryptography module, which we will use in our project, and we will check if it is properly installed. Now we have to set up our basic file structure. We have to go to desktop, go on new, and create a new folder. Let's rename the folder. We will rename it as Ultimate Python Ransomware. And yes, then we will open the folder, and here we will create our new file. Let's go on new and then go to the text document. Here we will rename it as encryptor.py, and we will open it via VS Code. Yeah, you can use any type of editor you are comfortable with, but in my case, I will be using VS Code. Now let's start by importing OS. We have to write import OS, and then from cryptography dot hazmat dot primitives import hashes. Yeah. Now from cryptography dot hazmat dot primitives dot kdf dot pbkdf to import pbkdf to hmsc. Now from cryptography dot hazmat or like dot, why is not this one back? No. Hazmat dot backends im- import default backend. Yeah, and then we have to import our last library for now from cryptography dot hazmat dot primitives dot ciphers import mods algorithms and the last cipher. Yeah, so uh, first we have to make two comments like here we will declare our all functions, and then here we will declare our all variables. So we will set our first variable as passphrase and give it your password, like it can be anything. Like in my case I'm writing my secret code. We can make it a strong one by pbkdf2. Yeah, so we will start our writing function first. For first function def generate key. I will pass two parameters, passphrase passphrase and salt. Okay, now next function def. Okay, before moving to the next function, we have to convert our passphrase into binary. So we will return kdf dot drive. Uh, okay, we have write comma dot drive passphrase dot encode. Okay, we are again write comma dot. Okay, dot utf-8. And now we will move on our next function def encrypt aes, and we will pass two parameters here, key and the plain text. Okay, plain text. After this we have to set the iv, so iv is equal to os dot u random and 16. Okay, next we have to write cipher variable and we will call cipher brackets and algorithm dot aes and here we pass key and mode as we are using CFB mode. So .cfb and we will pass the IV. Okay, next we will call backend, default backend, and now we will type our encryptor. Encryptor is equal to cipher.encryptor. Yeah. Okay. Now we have to final is okay cipher text. We will update it and then we will finalize. So encryptor dot update and plain text and plus we will finalize it. Encryptor dot finalize and then we will return IV and the ciphertext. Yeah, yes, ciphertext. Okay. Now we will move on our next function, def. Okay, def encrypt file, and we will pass here file path. We will pass here file path, and the passphrase. Yes. Now we will use try and accept. So accept exception as E and print in error encrypting file. Here I will show the file path and the error we call E in the curly brackets. Yeah. Okay, now move back to the try block and go if file path ends with. Now we have to add an extension. I am adding v codex. So v dot v codex. Yeah, and I will print this file. Okay, file, and I will show the file path. File path is already encrypted. Yeah, skipping. Okay. Uh, Now with with okay, before that we have to return and with open dot. Okay, open, we have to open file and we will read in binary as f, and plain text is equal to f dot read. Okay, now we have to create the salt is equal to os dot to random 16. Yes, and key is equal to generate key, and the parameters passphrase and salt. Okay, now cipher text is equal to encrypt AES. I have to pass key and the plain text. Yes. Now encrypt file path, file path plus v vcodex, and with open encrypt file path right binary. Okay, and sf plain text plus plain text is equal to f dot read, f dot write. Yeah, so write salt plus ciphertext, and os dot remove file path, the original one. Okay, so now I will set the file path. I will go. So guys, here we made some mistakes. First of all, a typo mistake. We have to write encryptor and we write it as inceptor, and then we don't have to put it in a variable plain text. We have to remove that. Okay, and now we will try our code, and we have to write R because of the spaces. And here I have created a folder samples, and I have pasted some documents, and let's try it first. Contact.vcf, and okay, everything is set. We have to remove the quotes, and we have to start. Okay, we have to. Okay, now we'll call the function. Now I will run this script and see if it works. And here you can see the contact.vcf is now encrypted. If I rename it, and I will show you, it will be, it is crashed. Okay, I will open and you can see it, it is now crashed. Okay, now let's try the other files, like this HTML file. Okay, I will copy the path and change path. Okay, remove the double quotes and run the code. Okay, now you can see it is encrypted as well. Now if I remove the extension vcodex and open the file and try to open the file, you can see the code is encrypted. Okay, now close it and let's try another. Paste here, remove the double quotes and run the code, and it's encrypted too. Yes, our code is running well, and let's try this last one. Copy path, place it here, run the function, and our code is running fine. Okay, now let's check if it's skip. Okay, what is it is showing? It is showing that this file don't exist. Uh, okay, let me see what is happening. Hmm. hmm, File is there, but it is showing that file does not exist. Okay, we have the error falling here, and try to run it again, and uh, it must show the skipping part. The file is already skipped, encrypted and skipped. Why it is showing that file does not exist? Okay, let's try run it again. Okay, okay, guys, we have error in the file path. We have to add extension vcodex, and let's see if it worked well. So it is working well. It is showing that the file is already encrypted. So, guys, we call it a day for now. Please don't forget to subscribe and please press the bell icon for updates. Thanks.